Hi, in this video, we're going to talk about stateless DHCP configuration. If you'd like more information on DHCPv6, stateless, stateful, whatever, please take a look at my book, my second edition of IPv6 Fundamentals, or the live lessons video. That's where a lot of this information comes from. So there's more detailed information there if you're interested. Of course, a lot more on IPv6. Okay, so remember, it all begins with the ICMP v6 router advertisement message. And a router to send out those router advertisement messages must be configured as a IPv6 router, and that's done using the IPv6 unicast routing command. Okay. It will not send out those router advertisement messages unless that command is configured. Okay, so we can see here there's actually three methods. So in other videos, I talk all about Slack. So that's where there's no DHCPv6, involves stateless or stateful. In this video here, we're going to talk about configuration of the second method, stateless DHCPv6. Okay, and we're also, in other videos, I'll talk about stateful DHCPv6 method 3. All right. So just a reminder, methods 1 and 2, okay, and that's including stateless DHCPv6. Okay? The client is going to create its IPv6 address information, its global unicast address, using Slack, okay, using the information in the router advertisement. The stateless DHCPv6, which is the option we're going to look at here for configuring the stateless DHCPv6 server, that's only going to provide information that's generic to everybody, like the IPv6 address of the DNS server or a domain name. All right, let's get started here. Okay, so we're going to look at method 2. Now there's three flags in the router advertisement message. Okay, there's the A flag, the O flag, and the M flag. Okay, so we talked about these in previous videos, but it's that A flag that means using Slack. That's on by default. So device we use, we'll see here in a moment, the prefix in the router advertisement to create its own IPv6 address. The O flag, which says use stateless DHCPv6, is off by default, and the M flag, the managed flag, to use stateful DHCPv6 is off by default. So what we want to do here in this mode here, what we want to do is actually we want method 2. So method 1, we're going to leave that A flag on by default. Method 1, but method 2, we're going to use Slack. So we want the A flag on by default. Want it to still use the prefix to create its own IPv6 address. But we're going to turn on the O flag, okay, the other configuration flag, to tell it to go get some generic information from a stateless DHCPv6 server. Okay, let's continue. There we go. There's method 1, but we're doing actually method 2. Sorry about that. All right, so just a reminder. So the device, when it boots up, it's going to send out a router solicitation message. The router will send back a router advertisement message, or sends it out periodically every 200 seconds. Okay, now by default, the A flag is 1. We're going to set the O flag to 1. Okay, so I'm going to show us how to do that in a moment. And we'll leave the M flag at 0. Okay, so the client will create its own address. Okay, and also get the default gateway address information from the router itself, but it's going to use DHCPv6 to get stateless information. Okay, so we'll show how this works in a moment, but just want to show the stateless or the DHCP V6 message exchange. Similar to that in DHCP for IPv4, just different names. Sends out a solicit message. Hey, who out there is a DHCPv6 server? The DHCP server, in this case will be our router, will send back an advertised message. The client will send back a information request saying, I accept that information you're advertising. And the DHCPv6 server will send back a reply saying, I'm acknowledging that you received this information. Okay, so let's take a look here. On the router, we want that O flag set to 1. We want to tell the client that other configuration information is on a stateless DHCPv6 server. So we do that by doing IPv6 ND. That ND stands for neighbor discovery, other config flag. That sets that O flag to 1. So that's what this is doing. Okay, all right, good stuff. Let's see how it works. So here's our router advertisement sent to all IPv6 devices from its IPv6 address of its on this interface, which is uses its link local address. It's only good for the link. Okay, all right. Sends out a prefix and a prefix length. The A flag is set to 1. That's done by default. And we've set the O flag to 1 by that previous command. The receiving device will see the prefix and go, oh, that's the prefix of this network. Okay, great. I know what the prefix portion of my network address will be. Knows the prefix length. Okay. Oh, address auto, the A flag, that's set to 1. Okay. All right. So I'm going to use the A flag set to 1. Let me back up here. That A flag set to 1 means it's going to create its own addressing information. Oh, it came from that source IPv6 address. That's my default gateway. So that's how DHCPv6, remember, I'm sorry, that's how IPv6 devices receive their default gateway address information. The DHCPv6 server never includes a default gateway address. Okay? So the device just basically uses the prefix information and then creates its own interface ID using either EUI64 or a random 64-bit value. We've seen that in previous videos. Okay? So there's its global unicast address. Okay? But remember that other configuration flag is set to 1. So it's going to request from a stateless DHCPv6 server other information, maybe a DNS address or a domain name, whatever is on that server. Okay, so that server is going to provide anything that's configured to provide with. We'll see how this works. All right, so let's take a look. Here's the commands, but I'm going to go through it in an example here after I show you all the commands here. All right, so the important thing here is there's no client address information that's being provided. The router acting as a DHCP server, a stateless DHCPv6 server, is only going to provide the DNS server address and a domain name. So let's take a look at the actual configuration of this. Okay. All right, so we're going to be configuring the router to act as a stateless DHCPv6 server. So the DNS server is out here someplace. Okay. All right, the device has created its own IPv6 address information. So it's going to get the rest of this information, the DNS server address information, from the DHCPv6 server. Okay, all right. So the IPv6 unicast command, that's required to send out the router advertisement by the router. Okay. On the gig00 interface, we've set the O flag to 1. That's the IPv6 ND other config flag command, setting the O flag to 1. We're telling the device you need to get other configuration information from a DHCPv6, stateless DHCPv6 server. Okay. And it's saying, you know what? When you send out that DHCP solicit message, when you're looking for that server, hey, I'm that server. I'll act as a stateless server. Now, I've used this name, IPv6 stateless, put it in all caps. That's just the name I gave it, so I know this pool is a stateless pool. Okay. And what it includes is a DNS server address and a domain name. Notice it provides no address information for the client itself. The client itself is going to use Slack, as we saw, to create its own global unicast address. Okay. All right, so we can see that it has done that. Okay, so this information here came from the router advertisement. It created its own IPv6 address using the prefix in the router advertisement and a random interface ID. The default gateway was the source IPv6 address of the router advertisement. Okay. There we go. All right, and the bottom information, the DNS server address, okay? That came from the stateless DHCPv6 server. Okay. And we can see that if on the router when we do show IPv6 interface gig 00, notice it actually says here, hosts use stateless auto-config for addresses. That means the A flag is set to 1. That means hosts are going to create their own global unicast address. Hosts use DHCP to obtain other configuration information. That means the O flag has been set to 1, and it will ask a stateless DHCPv6 server for other information. All right, that's stateless DHCPv6.